in this video we are going to talk about like how to make this tesseract effect. Okay, and it looks fairly complex. You can see, it has like lots of details and everything, but I'll show you like an easy way to get this up. Okay, so what we are going to do is like we'll just take a small sphere and we are going to emit some smoke to create some velocity fields, and we are going to advect the particles along that velocity field. Because the smoke cannot stick to the surface and all, we are going to use some conditions for the particles. So when we advect the particles based on the velocity field created by the smoke, we'll make sure to make the particles stick onto this box, and like get these really small interesting small details going on over here. Okay, alright, so let's start with this thing, and I'll make a new geometry folder. Okay, and I'll just make a sphere over here. This sphere is going to be it's going to be my emitter, and I'll put the center over here, and let's decrease the uniform scale. I just want a small point from where I can emit this thing, and let's increase the rows and the columns. Okay, then I will put a mountain over here so that our emitter, it has like little bit of noise to it, and I'll use the element size like 0.1 or so, and something for this amplitude. Let's go to the animation and let's turn on the animate noise, and this will be animated. Okay, so the first thing is like emitting this smoke. So I'll be using a pyro source which will create some points on our geometry, and at the same time it's also going to set up some attributes. So I will just create a density attribute. Okay, and just make sure this is set to like like by default this is set to keep input. Just change it to like volume scatter, so it's going to scatter points inside the object. Okay, I'll put the particle separation to 0.2 or so, it will make more particles, and just change the display particles to like pixels so that we can decrease the size and see them easily on the viewport. Okay, now what I need to do is I'll add a volume rasterize attributes, because smoke or anything related to the Pyrosolver, it only works with the densities, it does not work with the points. So if you don't know about these basics, just make sure to go to our channel, and you can watch some basic tutorials about smoke and all, and you will be good to go with these parts. Okay, so we have rasterized the density, and if you look at this, I'll just do one more thing. I'll connect all of them, all the voxel size together. Just before that, I'm going to create some velocities as well. Okay, so I want to throw the smoke into this random direction, so I'll just call this density. We call this density, and I'll just make a duplicate of this, and over here I will add a point velocity. So point velocity is going to generate some velocity vectors for us. Okay, let's click on this curl noise, add curl noise, and if we look at this, so these are the velocity vectors which are generated. So this is like this is going to throw our smoke in all the random direction. Okay, now we need to rasterize the velocity as well, so we'll do the same thing. So instead of density, we'll choose the velocity, and we'll get something like this. Okay, that works. Let's use a merge, and let's merge both of them together. Okay. So over here we have the density and we have the velocity as well. Let's put up a null here, and let's merge both of them. Let's do a control C, and I'll come back and I'll make a new .NET, and I'll call this Pyro. Let's go inside this. Let's add a smoke object. Make sure this is set to sparse, because we are going to use the sparse solver, and let's use the pyro sparse, and let's use a volume source. Once again, if you don't know about the basics, just make sure to watch the tutorials. We have a complete basic to advanced series for the smoke. In the volume source, I'll paste the path. I'll go to the volumes and I'll click on this operations. Make sure you check this enlarge field to contain sources, so that your Pyrosolver will know where the volume source is. Okay, and here I'm going to create a density field for the incoming, which goes to the density field, and I create a velocity field which goes into the well field. Okay, let's try to do the same and let's see what we get. Okay, so we get some basic smoke over here. Let's do one thing. Let's connect all our resolution. Let's copy the voxel size over here. Let's go back, and in the density, let's paste the relative references over here. Same with the velocity rasterization, and same with the pyro source. Okay, So let's go back to the smoke object, and I'll use something like 0.03. Once again, we don't really need to do a very high resolution smoke over here, because we just want to move the particles with the smoke. So anyways, the end result is not going to be the volume, so we can get away with some lower resolution stuff as well. What I'll do is I'll just go over here and I'll increase the velocity value, so the smoke will be a little bit more fast. And yeah, I think that works. What else we can do is we can also add some turbulence over here. So I can use a gas turbulence, and just make sure you put it into the right input, which is the fourth one. Okay, and let's use like 0.1 and maybe like 1 for the swirl size. I just want to break this smoke which is coming out. Okay, let's try to increase the scale. Let's try with 1 and let's see what do we get. Okay, yeah, okay, that looks fine. Maybe I'll use like 0.5 or so. Okay, now I want to make the box for the tesseract. Okay, so what I'm gonna do is I'll use this sphere and I'll connect a box over here. So it's going to create a box which will be same size as our original sphere, and then I can just put a transform. You cannot do this. You can just create a box separately. That will also do the same thing. Okay, but I can just use this, and I'll do a right click, pivot mode, and I'll just make sure to center my pivot. Okay, now let me just scale up the box. Okay, something like this, and yeah, that looks fine. And I'm just going to rotate it so that it faces in a more interesting way towards the camera. Okay, and then I can, if I want, I can decrease the scale. Okay, so right now this box is like solid, so I want to make it hollow so that we can collect the smoke inside this box. So I'll just use a poly extrude over here, and I can just change it to the wireframe, and I can click on this output back, and I think 0.1 will be fine for this. Okay, alright, so let's null this out and let's call this collision. Let's do a control C. Let's go back and let's use a merge and a static object. Okay, so in the static object I'm just going to paste the path, and I want to see like how my collision guide is looking, not the collision but the collision guide. So I'll turn off this display geometry. Let's go to the collision and turn on this collision guide, and you can see like it's not really making the box really good. So we can just increase this uniform subdivision and we will get a proper box. That's it. Let's turn off the collision guide. Let's turn on the display geometry. And okay, so I'll just turn off the display geometry and let's see how the smoke behaves with our geometry. Okay, so we can see it goes towards the sides and it interacts with the box, and that is what we want. We just want some initial velocities, because the particles will be getting carried along, and they won't really die. Right now the smoke is dissipating, so it feels a little bit awkward. So if you want to see the smoke properly, what you can do is you can go into this Pyrosolver shape and you can just turn off this dissipation, and then you will see how the smoke collects inside this box. Okay, so I can just keep it on. It's not about the smoke, it's all about the velocity fields, which are always there. Okay, alright, so I think that looks fine, and maybe I can go with a high resolution. I'll just use like 0.02, and that is also fine. Okay, all cool. Let's do a control C, and I'm going to bring this data onto the DOP level. So let's use a DOP IO, and over here I'll paste the path into the DOP network, and I can use the Pyro here. So let's go forward a few frames, and you can see we'll start to get the Pyro here. Also you can just paste this path onto the DOP node, and you can just force it to like only bring the smoke object, so it won't bring any collisions or anything. Okay, it won't bring the static object and all. Okay, alright, so yeah, this thing works. Okay, and now if I null this out, you can see we have a velocity field over here. Okay, and this is going to be used to derive the particles. Okay, alright, so now we are starting with the particle simulation, and we need an emitter for emitting the particles. So the emitter could be the same thing from where we have emitted the smoke. Let's just null this out from the mountain, and let's call it emitter. Okay, let's do a control C, and we'll be making a new DOPNet. We can just call it particles. Let's go inside this. Let's add a pop solver. Let's add a pop source, and let's add a pop object. Okay, let's put all of them together, and we get something like this. Okay, we don't need any gravity because this is not a realistic simulation. This is more of an artistic thing. Okay, so in the pop source, we can just paste the path over here, and you will see it will start to create particles over here. Let's go to the guide. Let's turn it off. Let's go to the birth, and let's zero out everything. And in the impulse count, let's put this thing to like 1. Okay, so it's going to create 1 particle every frame. Let's put it to like 1000, and it's going to create 10,000, like 1000 particles every frame. So after 10 frame, it's going to create 10,000 points. We'll be increasing this even more. As of now, I think this is fine. Let's do one thing. Let's go back and let's copy the velocity field that we have created. Okay, let's come here and let's use a pop advect by volumes. So pop advect by volume, what it does, it takes the velocities from the any velocity field. It takes the velocity from the volumes. It could be flip or it could be pyro, and it can advect the particles throughout that velocity field. Okay, so if I paste the path over here, and if I turn on this guide, you can see like it will start to show us some movement here. Okay, so it's the velocity fields which are being which are getting created. Okay, let's turn it off, and just make sure to turn off this treat as event. So that will make the particle movement a little bit more interesting. If you turn on the treat as event, it's like kind of a drag effect which is added, which I don't really like. Once again, that is like up to you. You can try with different values. So you can see these particles, they go on for like forever. Let's go back and let's copy the I'll go to the pyro and I'll copy the static object. So because I want these particles to like interact with the tesseract. Okay, let's paste this here. Let's connect both of them and let's do this sim and let's see what we get. Okay, now you can see we have these particles which are getting created inside this box, and we get something like this. Okay, let's go to the pop object, and right now you can see like these particles, they're interacting with the box, but they are jumping around. So what I'm going to do is I'll just go to this physical and I'll put the bounce and bounce forward to like 0. Okay, so these particles, they will go to the box and they will like kind of stop over there. You can see like they are like still kind of moving, and that is due to the velocity field which is still existing inside the smoke simulation. Okay, so I mean that is fine. I mean that is all what we want. We have already done most of the part. There's just one more thing which I want. What I want is like when these particles they stick to this surface, what I want them to have is I want them to have like some small motion going on over here. I want to add some small details over here because that will make things look even more interesting. So I need to detect when they collide with the box. In order to do that, I'll be using a pop collision detect. I'll put this one over here, and you'll see like as soon as the particles they collide with the object, they go into this, they get this new color. So what we want to do is we want to go into this behavior, click on this group name, and let's call them like you can just call them collide. Okay, turn on this preserve group so that they won't be cleared out, and I mean we can just turn off this color hits. Okay, so when they collide with the with this box, they'll be sent into a new group, and you can see like we have all these collide particles here. Okay, now what I'm gonna do is I will just add a pop wind over here, and I'll make sure this pop wind only works on this collide group and not everything. So what happens is it's not going to affect anything, but as soon as it hits the walls, I'm just going to turn it on, and I'll use sword size for like 0.25. So I just want to have very small details, small movements. So you can see like as soon as it hits the wall of the tesseract, it gets those small details and small energy and all, which makes it look really good. Okay, so once again, this is the process of R&D. I've been going through the references and all those things, and I found like doing this just gives a really good look. Okay, all right, so I mean, I think that looks good. Okay, we can turn on our we can increase the impulse count, and let's do a quick render and let's see what we get. Okay, and for the final render we are going to increase the particle count even more. So let's go to this 73rd frame or so. Okay, and I'm going to bring all these particles to a new level. Okay, so I can call it like I can call this setup. Okay, and I'll make a new geometry folder over here, and let's call it render particles. Let's go inside this and let's use a .io instead, and let's go to this DOP network option here, and let's paste the path. Okay, and over here let's choose the particles. Okay, so it will also bring the static object. So just copy this, just paste it over here, and we'll make sure that we only import the pop object. So it won't be bringing the static object and all. Okay, so if we look at this, again we just have the same simulation brought to the SOP level, sorry, and let's try to render this out. Okay, and like there are some particles which are going out, and the thing is like if you let them leave, I mean this is I accidentally found this this happened in my simulation because the smoke, like the object was not thick enough, and some particles they left the simulation, but in return I got something really cool. So we'll just keep it as it is, and I'm not really going to cache out anything right now, so I can just click on this null. Let's do a control C, and let's create a new camera over here, and let's lock it to the view. Okay, so let's see how does it look when we render it out. So let's go over here, let's create a new shader, and I've seen a lot of people, they really mess with the shader to get something cool looking, but we are going to do it as usual, really easy. Okay, so let's put the principal shader over here, let's put the albedo multiplier to 0. I don't want any reflection, I don't want any color, all that I want is the emission. Okay, so for the emission I'll be just choosing some bluish color. Okay, and let's see how it looks in the render. Also I'm going to go to this like output settings. Okay, and here we have this option of rendering. Okay, and I'll just change it to the micro polygon rendering. So what happens with micro polygon rendering is you can choose micro polygon rendering or micro polygon physically based rendering. I think physically based will be like little bit better, but I think it's they're kind of same. So these are like really good when you're only rendering particles. Okay, alright, so right now you can see like we get these bubbles kind of shape. So let's go to this render option, geometry, and here we have this point scale. Let's keep it to like really small value, let's use like 0.05. Okay, and now you can see we get something, but it's not really looking glowing or anything. Okay, so there's nothing like glow, it's all about the variation in the alpha. Okay, so in this emission color, first of all what I'm going to do is like I'm going to make everything a little bit more dark. Okay, and now if you see over here right now almost everything has the same alpha, so the alpha value for everything is same. So in order to like get some glowing kind of thing, what we need is like we need some variation in the alpha. So like wherever there is like when the particles they overlap, they can have more alpha, and when like wherever the particles are less they can have less alpha. So what I can do is I can go into this opacity mode, and I can put it to like 0.01, and you can see right away we start to get something like this. Okay, alright, so let's go to the principal shader. Okay, and just make sure there are two things which you need to make sure. First of all, your overall color should be really dark, and second thing is the saturation should never be 1, otherwise you won't get that white core kind of look. And you can see right away we start to get something really good looking. Okay, there are a few more things which I'll change. I'll go back to the object level. In this render I'll go to this sampling option, and I'll turn on this velocity blur. Also I'll go to the output for the mantra, and I'll click on this allow motion blur. So we will have some motion blur going on over here. The motion blur values can be controlled by the camera. Make sure to have a camera, and if you go into this sampling option, if you increase the shutter time, you will have more and more motion blur. Always make sure to have motion blur whenever you are dealing with any energy kind of effects. Okay, alright, so I think that looks good. I'll just do one more thing. I'll just go back and I'll just increase the particles count 1, and let's see how it looks. Okay, so I'll just increase the particle count 10 times, and let's see how it looks. Alright, so yeah, I think let's render it out now. Let's see how it looks, because we have increased the particle count. This is going to look much more better. Yeah, and you can see we get something like this. Alright, so let's go to the principal shader, and in this emission color we can make it a little bit more dark. Right now it's looking a little bit washed out, and I think yeah, that looks really good. Okay, and I think we can just make it a little bit more dark. Okay, and for the saturation we can just play with this value. Okay, alright, so I think that is it. That's how easy it is. Okay, one more thing, I'm not really going to cache out anything, because when you cache out the particles, they get so high. So you can even simulate stuff without caching, or if you want you can just cache out stuff. You can watch our old tutorials, and you can see if you don't know how to cache out stuff, just watch our old tutorials, and you'll be able to understand everything. Okay, now let's see how we can render every frame out. Let's just go to the output, and here we have this option of mantra. Just choose the camera, change this to like render frame range, okay, and go to this images output picture, and I can just make a new folder anywhere you want, and let's just call it render tesseract, and let's put a $f.exa, and that is it. Just click on render to disk and you will have the complete simulation animation over here. Okay, so that is it. I hope you guys have liked the video. If you do, just make sure to subscribe and just watch out more tutorials. If you want to learn more about Houdini or animation, you can always contact us from our website. All the details are given below in the link. Okay, so that is it. Let's meet in the next tutorial. Bye bye.